Good evening, everyone. Now today I am going to explain the quadratic equation, which is the last exercise of class 11 mathematics. So now this is welcome to my channel mathematicsrose, or our channel, we can say our channel mathematicsrose, and by Sajid Akhtar or Sajid Akhtar. Now, as we know that a quadratic equation is the equation whose power of the variable, in which the power of the variable is always 2. We know that the general form of the quadratic polynomial is ax square plus bx plus c, which is equal to 0. And here a, b and c are real numbers, and a is not equal to 0, because we know that if a is equal to 0, it will first term will vanish. So this is the quadratic polynomial general form, and if it is equal to 0 or any number or equal to 0, then it is the standard form of the quadratic equation. So if you will solve it by completing the square, we will get x is equal to minus b plus minus root under b square minus 4ac divided by 2a, where you know that d is equal to b square minus 4ac. And in class 10th, when d is less than 0, means d is negative, that time square root of negative number is not a real number, so it does not belong to the set of real number. So we have not studied regarding the imaginary number or complex number. Now we know that the complex number is the set of all ordered pair by W.R. Hamilton, in which suppose in a ordered pair, suppose A and B, which can be written as A plus IB. Suppose that ordered pair I am writing AB, where A and B both are real, and it represents A plus IB, where iota is root under minus 1, and any complex number can be written as the ordered pair of two real number is given by W.R. Hamilton, which is W.R. Hamilton, where iota is equal to root under minus 1. This value is this unit of imaginary number is given by Euler. So now here when the quadratic equation is equal to 0 and discriminant is less than 0, means square root of d will be imaginary number, and we know that the sum of the real number and imaginary number is always equal to a complex number. Suppose that we will take 2 and root under minus 5, to 2 plus root under minus 5 is always a complex number, it belongs to C. So this is and complex number contains all the real numbers and imaginary numbers also. So, and we can represent the complex number in Argand diagram. So this formula is derived by Sri Dhanacharya. This is the formula by Indian mathematician Sri Dhanacharya. So a polynomial of having degree 1, a polynomial whose degree is 1, means a polynomial at degree is 1, that is which type of polynomial? Ax plus b, and it is equal to 0, means this is the linear polynomial, and where a is not equal to 0 and ax plus b is equal to 0. So at least one, if we will find the value of x, it will give x is equal to minus b by a. It means that a polynomial whose degree, a polynomial equation whose degree is 1 is always has a one root. So algebra fundamental theorem of algebra says that a polynomial equation has at least one roots or solution. It may be complex or but at least one root will be real. Suppose a polynomial. Suppose we will take a polynomial equation. Suppose x plus 2 is equal to 0. So x is equal to minus 2. So it has at least one root, and x plus 2 is equal to 0. So this is called a polynomial equation because its left hand side is a polynomial. So every polynomial, suppose if we will take the polynomial of degree 2, so it is a quadratic polynomial. When the quadratic polynomial is equal to 0, it will give the quadratic equation, which is in the form of this. So it gives the quadratic equation, and where this part is quadratic polynomial. This part is quadratic polynomial, and every quadratic polynomial or every quadratic polynomial equation. This is the quadratic polynomial equation. It means that it is also called the quadratic equation. So every quadratic equation has two solutions or two roots. So x has two values. X has two values which are minus b plus minus root under b square minus 4ac divided by 2a. Okay. So a polynomial, suppose a cubic polynomial, if we will take any equation x cube plus 1 is equal to 0. So it means that x has how many number of roots? It has 3 roots, because we know that the cube root of unity is equal to 1, and then first is 1 and second is cube root of unity. We know that the first is 1 and other is omega, and omega is square, and that is the solution of x cube minus 1 is equal to 0. So similarly, we can find out the solution of x cube plus 1 is equal to 0. So how many number of roots we will get, whether it will be a real roots or complex roots. So it has 3 roots. So similarly, a polynomial equation whose degree is n. Suppose a polynomial equation whose degree is n has how many number of roots? Number of roots will be n. This is not a fundamental theorem. This is not the fundamental theorem of algebra. Fundamental theorem of algebra says that a polynomial equation has at least one root or one solution. This is called the fundamental theorem of algebra. Suppose a cubic equation I have written over here, 2x cube plus 3x square plus 4x minus 8 is equal to 0. So it has this is the cubic equation. So power of x is 3, and it is a cubic polynomial also. Left hand side is the cubic polynomial. So it is how many number of roots? So it has 3 roots. And suppose x to the power 5 plus 1 is equal to 0. So it is a equation whose degree is 5. Therefore, it has how many number of roots? So 5 roots. 5 roots we can find. Okay. I will show also in another video. But here we have to concern or we have to restrict ourselves in quadratic equation. So solve x. So first question is from exercise 5.3. I think this is exercise 5.3. Exercise 5.3 ncert. I have made the video of 5.2. I will just release it. So now solution. Here is x square plus 3 is equal to 0. So x square is equal to minus 3. So x is equal to root under minus 3. you will have to take plus minus both value. So x is, therefore it implies x is equal to plus minus root under 3 into minus 1 you can write, and plus minus root 3 into root under minus 1, and this implies that x is equal to plus minus root 3 into iota, since iota is equal to root under minus 1. So the solution are x is equal to root 3i, and the second is minus root 3i. So there are two solutions and both are complex numbers. So it is quite clear because it has the quadratic equation. So every quadratic equation has two solutions, whether it will be a real solution or complex solution. So now we are coming to the next one. So here the question is question number 2. 2x square plus x plus 1 is equal to 0. So a is equal to 2, b is equal to 1, and c is equal to also 1. B is 1 here. So therefore x is equal to minus b plus minus root under b square minus 4ac divided by 2a. This is the formula given by Sri Dhanachar by completing the square method. So minus 1 plus minus root under 1 square minus 4 into 2 into 1, a is equal to 2, and divided by 2a. 2a means a is equal to 2. So minus 1 plus minus root under, it is 8 and this is 1. So minus 7 root under minus 7 divided by 4, and now this can be written as minus 1 and plus minus root 7 and into root under I. So root under minus 1, and therefore it is equal to minus 1 plus minus root 7 I by 4. So this is the solution. So x has two values over here. So one is minus 1 plus root under 7 I divided by 4, and other is minus 1 minus root under 7 I divided by 4. So this is the answer. Hope you will understand it. Now next is similar type of question. Here is 1. So coefficient of x square, a is 1, b is equal to 3, and c is equal to 9. C is equal to 9. Now x will be minus b plus minus root under b square minus 4ac divided by 2a. So this is minus 3 plus minus root under 3 square minus 4 into 1 into 9 divided by 2 into 1. So minus 1 plus minus, it is 9 minus 36 divided by 2, and minus plus minus and subtract over here. So it is root under minus 27 divided by 2, and now 27 can be written as minus 27 can be written as minus 9 into 3 and into 3 divided by 2a. So it is minus 3 plus minus 3 root 3 into root under minus 1 will come, because this is minus, and so minus root under minus 1 is coming. So divided by 2, so it is equal to minus 3 plus minus 3 root 3 I iota divided by 2. So it has two solution again. So now we are coming to, now the next question is question number 4. Here the quadratic equation given minus x square plus x minus 2 is equal to 0. So a is equal to minus 1, a is equal to minus 1, b is equal to 1, and c is equal to minus 2. Therefore x is equal to minus b plus minus root under b square minus 4ac divided by 2a, so it is equal to minus 1 plus minus root under b square means 1 square minus 4 into minus 1 into minus 2, so divided by 2 into a minus 1, so here see minus 1 plus minus root under 1 means 1, so minus minus plus and then minus, so minus 8 divided by minus 2, so it is equal to minus 1 plus minus root under minus 7 divided by minus 2, so it is equal to minus 1 plus minus root under 7 into minus 1. We can write minus 7 by minus 2, so it is equal to minus 1 plus minus root under 7 into, you can write I square, minus 1 is equal to I square. Since minus 1 is equal to I square, yes, over here, so minus 1 is equal to I square, this is okay, so divided by minus 2, so it is equal to x is equal to minus 1 plus minus root under 7 I divided by minus 2. So these are the two solutions, and now we are coming to the next question. Now question number 5. Question number 5 is x square, so plus 3x plus 5 is equal to 0, so a is equal to 1, here coefficient is 1, so b is equal to 3, c is equal to 5. Now x is equal to minus b means 3 plus, now I am not writing the formula again, so 4 into a into c, 4ac divided by 2 into a, so it is minus 3 plus minus, here will be minus, so plus minus 9 minus 20 divided by 2, so it is minus 3 plus minus root under minus 11 divided by 2, so it is equal to minus 3 plus minus root under 11 into I will come, and then this is, so there are two solutions, one is minus 3 plus root under 11I by 2, and second is minus 3 minus root under 11I divided by 2. So this is the answer. Hope you will understand it. And now we are coming to the next question. Next question is x square minus x plus 2. So coefficient of x square is a, that is 1, b is equal to, this is minus 1, so it is minus 1, so c is equal to 2. Constant term is c, so x is equal to, here the variable is x, so minus b minus minus 1 plus minus root under minus 1 square 4 into 1 into 2 divided by 2a, so 2 into 1, so here we can write plus 1 and then plus minus, it is 1 minus 8 divided by 2, so it is equal to 1 plus minus root under minus 7 divided by 2, so this can be written as 1 plus minus root under 7I by 2. So x has two solutions, 1 plus root under 7I divided by 2, and second is 1 minus root under 7I divided by 2. So x has two solutions because it is the quadratic equation. So now we are coming to the next question. Now next question is question number 7, and here so question is root 2x square plus x plus root 2 is equal to 0. So here solution is a is equal to root 2, b is equal to coefficient, this is 1, and c is equal to root 2. So therefore x is equal to minus b plus minus root under b square minus 4ac by 2a, so minus b is 1, minus 1 plus minus root under 1 square minus 4ac root 2 and divided by 2a to 2 root 2. So it is equal to minus 1 plus minus root under 1 minus root 2 into 4. So it will become 8. So minus 8 by 2 root 2. So it is equal to minus 1 plus minus root under minus 7 by 2 root 2. So it is equal to minus 1 plus minus root 7I divided by 2 root 2. So therefore, if you will rationalize the denominator, we will multiply by root 2. So it is minus root 2 and then it is plus minus root under 14. This root 2 into root 7 root under 14I divided by this is 2 into 2. So 2 into 2. So here will be minus root 2 plus minus root under 14I by 4. So there are two values of x, minus root 2 plus root 14I by 4, and second is minus root 2 minus root under 14I by 4. So there are two solutions of this equation. So hope you will understand it. So now we are coming to the next question, question number 8. So question number 8 has equation root 3x square minus root 2x plus 3 root 3 is equal to 0. So a is equal to root 3, b is equal to minus 2 root 2, c is equal to 3 root 3. So now x is equal to minus b plus minus b square minus 4ac divided by 2a. As you know, so it is minus root 2. Minus root 2 is this, so plus minus and minus root 2 square. Here is minus root 2 square minus 4ac. A is root 3 into c is 3 root 3 divided by 2a means root 3. So here will be plus root 2. This is plus root 2 and then plus minus root under 2, and here is 12 into 3. So minus 36 divided by 2 root 3. So see plus root 2 and it is plus minus root under minus 34 plus minus subtract and then negatives will come. So 2 root 3. So here it is 34. So root 2 plus minus the root under 34 and then you can write I outside the square root I 2 root 3. So in this way, here we can rationalize also the denominator. We can rationalize the denominator also. Just a minute. So here if you will rationalize it by root 3 multiplying by root 3, it is root 6 plus minus and root 34 into 3. 3 4 is 12, 3 3 is 9, 10, 100, 2 I divided by here. This is 3. So 2 into 3. So it is root under 6 plus minus 100 2I divided by 6. So if we will take 100 prime factorization of 102, so this is 5 times 1, 3, it is 17. So we are not getting 2 times any number. So answer will be, answer is root under 6 plus root under 102I by 6, and the second answer is root 6 minus root under 102I divided by 6. So this is the answer. So hope you will understand. Now we are coming to next question. Here, see, this is the quadratic equation. So here we can just multiply the equation by root 2 both sides. Why? Because here is root 2. So we can take, if we will multiply over here, so this equation becomes root 2x square plus root 2x plus 1 is equal to 0. So each term is multiplied with, this is multiplied by root 2, this is multiplied, and this is also multiplied, and this is also multiplied. So it is 0 into root 2, so 0. So a is equal to root 2, b is equal to root 2, and c also equal to 1, not root 2, sorry. So x is equal to minus b plus minus root under b square minus 4ac divided by 2a. So minus root 2 plus minus root under b square means root 2 square, and then 4 into root 2 into 1 by 2 into root 2, 4ac. So 4 into root 2 and c is 1. So 4 into root 2, that's all. So minus root 2 plus minus, this is root 2 square means 2 minus 4 root 2 divided by 2 root 2, 2 root 2. Now this is larger one and this is a smaller one. So here this is negative, because this is larger one. So root 2 plus minus, we will take minus 1 common over here. So 4 root 2 minus 2 divided by 2 root 2. So this can be written as minus root 2 plus minus root under minus 1 into root under 4 root 2 minus 2 divided by 2 root 2, and this is iota. In place of that I will write iota minus root 2 plus minus root under 4 root 2, see. So minus 2 iota by 2 root 2, So we can rationalize also by multiplying the numerator and denominator by root 2. So root 2 into root 2, it is equal to here I am writing root 2 into root 2 minus 2, and then plus minus this root 2 root 2. So inside the bracket it will multiply. So 2 root 2 into root 2. So 4 into 2, and this is multiplied with this. So minus 2 root 2 I minus 2 root 2 I is outside. I is outside the square root, and divided by, this is root 2 into this root 2. So 2 and 2 into 2. So it is equal to minus 2 plus minus, it is 8 minus 2 root 2 iota divided by 4. So this is the answer of this question. So hope you will understand it. Similarly, now we are coming to the next question. Next question is this. So we will take LCM over here. Here x square. So suppose root 2 I have taken LCM. Here is 1. So here is also 1. So root 2x square, then x, then root 2. 1 divided by root 2 into 1. So root 2 is equal to 0. So bring root 2 in this side. So root 2 x square plus 1x plus root 2 is equal to 0 into root 2. So it is equal to 0. So a is equal to root 2, b is equal to 1, and c is equal to root 2. So now x is equal to minus b plus minus root under b square minus 4ac divided by 2a. So now minus 1 plus minus b square 1 square minus 4 into root 2 into root 2 divided by 2 into root 2. So now minus 1 plus minus it is 1 minus 4 into root 2, so it is 8. So 2 root 2, then it is minus 1 plus minus root under minus 7 by 2 root 2. So we can write it minus 1 plus minus root under 7 iota divided by 2 root 2. Now rationalizing, multiplying denominator, multiply numerator and a denominator by root 2. So here minus root 2, this we will multiply over here, and here we will multiply. So root 2 into root under 14 iota and divided by root 2 into root 2 and 2 into 2. So it is equal to minus root 2 plus minus root under 14 iota divided by 4. So this is answer will be x is equal to minus root 2 plus root under 14 iota by 4, or minus root 2 minus root under 14 iota by 4. So hope that they answer the question. So I think this is the question number 10. So we have done the exercise 5.3, which is the quadratic. Now this is the miscellaneous example, and now miscellaneous exercise also. Miscellaneous exercise on chapter 5. Now find the conjugate of this. This is the complex number which is not written in standard form. So first of all we will write this complex number by standard form by simplifying it and then conjugate. So let solution 3 minus 2i into 2 plus 3i by 1 plus 2i into 2 minus i. So here we will multiply, so it is 6, and then 9i, then 4i, then minus 6i square divided by, now we will multiply 2 minus i, and then 4i, then minus 2i square. Just simple multiplication. 1 is multiplied with 2, 1 is multiplied with minus I, 2i is multiplied by 2, 2i is multiplied with minus I. So this, so in place of I square, put I square is equal to minus 1. So now 6, and here will be plus 5i, and then minus 6 into minus 1, 2 here plus minus subtract, so plus 3i, and then 2 into minus 1, so it is equal to 5i, and then here I am writing 6, then it is also 6 plus 5i. Now here 2, and this is minus minus plus, so 2 plus 2, 4 we will write, plus 3i. So this is equal to 12 plus 5i divided by 4 plus 3i. Okay, so now we have to multiply its conjugate of the denominator, so that we will find out the complex number, the given complex number in standard form. So here we will multiply 48, it is 20i minus 36i minus 15 iota square, or I square, and here a plus b, a minus b, so a square minus b square, so it is 9i square. So it is minus 48 minus 15 into minus 1, this will subtract, so minus 16i. Here this I have written here, and now it is 16 minus 9 and iota square minus 1. see 48 plus 15 minus 16 iota by, this is plus, so plus, so it is 16 plus 9, so it is 25, so it is here I am writing 25, this and this 30 and this 6, this iota divided by 25. So now let us suppose this the conjugate of this complex number we have to find out. So this can be written as, let us suppose this is z. In the first I will take that, let us suppose it is z is equal to this. Now z is equal to this, so z is equal to 63 by 25 minus 16 by 25 I. Now conjugate of z bar is equal to, just you will change the sign, 63 by 25 and then here plus 16 by 25 I. So this is the conjugate of this complex number. So hope you will understand it. Not difficult question. Now here we have to find out. Now this is the question I have already written. Next example is example 2. Find the modulus and argument of the complex number, and the first complex number is this 1 plus I divided by 1 minus I and I, and second is 1 by 1 plus I. So here first of all we have to write this complex number in a standard form, and after that the standard form means a plus ib or x plus iy. So let us suppose that z is equal to 1 plus I. First one I am doing solution, so it is 1 minus I, now multiply by its conjugate of the denominator 1 plus I, 1 plus I. I'm just writing multiply by conjugate of denominator 1 minus I, that is 1 plus I. So here we will multiply over here, so 1 plus I, then I plus I square divided by a plus b, a minus b, so a square minus I square. Now put I square is equal to minus 1. So in that, after that, here I am writing, so 1 plus 2I minus 1 by, here is 1 minus 1, this is cancelled, so 2I by 2, so it is only I is coming, so we will compare it a plus ib. So we will just compare it a plus ib, so a is equal to 0 because the real part is 0 and ib is equal to I, so ib is equal to 1 by a plus ib is equal to I, and this can be written as 0 plus 1I. So if you will compare the two complex numbers will be equal, then the real part is equal to real part, imaginary part is equal to imaginary part. Now we know that the modulus of z, suppose the modulus of z here, the b is equal to 1 root under a square plus b square, so 0 square plus 1 square, so it is root under 1. So modulus is 1, and now argument of the complex number we have to find. So this complex number is lying between, if it is written in order of 0 and 1. So this complex number lies in which axis? In imaginary axis y o y dash. Suppose this is 1I. So here this complex number, this is 1 unit away from here. So this complex number, suppose this is a, its coordinate is 0 and 1, and this is represent I only. So how much angle it makes with the positive direction of x-axis? So this is 90 degree it makes, so therefore theta is equal to, we will write tan theta is equal to mod of y by x. So y is y by x, or here b by a, sorry. So b by a, so b is 1 and a is 0. So as you know that it is undefined, so tan pi by 2 is undefined. So theta is equal to pi by 2. So therefore argument is equal to theta. ARGZ is equal to theta, and it is pi by 2. So answer is pi by 2 argument, and modulus is 1. We have determined here. We have determined modulus is 1. Here see, modulus is 1. Modulus is 1 over here, and argument is this. So this is the answer, and this is also the answer. So hope you will understand it. Now we are coming to the next question. I have already written. So here we are coming to the next question. So here you just see, here it is given example number, miscellaneous exercise, example number 14. This is the example 14. E for example. Now, if x plus iy is equal to a plus ib divided upon or divided by a minus ib, prove that x square plus y square is equal to 1. So solution. Given x plus iy is equal to a plus ib divided by a minus ib, this 1. Now taking the conjugate of equation 1. Conjugate of equation 1 means we have to change the opposite sign of each complex number given here. So here, what is the sign of each complex number? Sign between the real part and imaginary part. Then we will get the conjugate. So here x minus iy, it is the conjugate of this, and here it is the conjugate of this is a minus ib, and here a minus ib, so its conjugate will be a minus is plus ib, or you can write in this way also. Just I am writing it, conjugate x plus iy is equal to conjugate a plus ib, the sign of the conjugate, and here the conjugate a minus ib, and this you will get. So this is equation number 2. Sign you have to change only. Now multiply equation 1 and 2, we get, see, this into this, we will multiply x plus y, iy, x minus iy, it is equal to a plus ib by a minus ib into a minus ib by a plus ib. This, so this and this will cancel, this is cancelled out, and here a plus b and a minus b, so it is x square minus I by whole square is equal to 1. So x square minus I square y square is equal to 1. So x square minus 1 y square is equal to 1. So it is x square y square is equal to 1. So this we have to prove, because I square is equal to iota square is equal to 1. So hence we have to prove this. So proved. In this way you can prove very easily. There is no problem at all. Now we are coming to the next question. The question number 15. Question number 15 says find theta for this complex number such that 3 plus 2I sin theta divided by 1 minus 2I sin theta is purely real. So when purely real, a complex number z x plus iy is purely real if y is equal to 0, means x is equal to z is equal to x. If y is equal to 0, means the terms related to imaginary part will vanish. When it will vanish, y is equal to 0. So this is the condition for that. So first of all, we have to write it in which form? Standard form. Standard form means x plus iy form. So let solution let z is equal to 3 plus 2I sin theta divided by 1 minus 2I sin theta. So we have to multiply it by its denominator of its conjugate, 2I sin theta, and divided by 1 plus 2I sin theta. So here multiplying numerator and denominator by conjugate of 1 minus 2I sin theta, that is 1 plus 2I sin theta. So here we are multiplying by this. I hope you understand this. So now we are multiplying this. Z is equal to 3 multiplied by 3 plus 6I sin theta, and now 2I sin theta into 1, so plus 2I sin theta, and here 2I sin theta into 2I sin theta, so 2 to 4 I square sin square theta, and this divided by, it is a minus b, this is a plus b, so it is a square minus b square, so 1 square minus 2I sin theta whole square. So now it is 3, and this is 8I sin theta, and this is 4 into minus 1 sin square theta. I square is equal to minus 1. We have substituted over here, and then we are writing in this way, and divided by 1 minus 4I square sin square theta. So here 3 plus 8I sin theta minus 4 sin square theta divided by 1 minus 4 into minus 1 sin square theta. So here 3 plus 8I sin theta minus 4 sin square theta divided by 1 plus 4 sin square theta. Now here the real part is this. This is the imaginary part. So you are understanding all these things here. The real part we will write together. This, so 3 minus 4 sin square theta. This is the real part, and imaginary part is 8I sin theta. Okay, and divided by 1 plus 4 sin square theta. Now this whole thing is real part, and this whole thing is imaginary part. So we can write, we can bifurcate it. 3 minus 4 sin square theta divided by 1 plus 4 sin square theta, and then here is iota into 8 we can write sin theta divided by 1 plus 4 sine square theta. So here this is in terms of which form? This is x plus iy form. So z is equal to here in this form. So when it will become an real number for real z, y must be 0. Imaginary part is 0. So this we will equate it. This value is equal to 0. So I sine 8 sine theta divided by 1 plus 4 sine square theta. 1 plus 4 sine square theta, it is equal to 0. So therefore I into 8 sine theta, so 0 into 1 plus 4 sine square theta, so it is equal to 0, and then sine theta divided by 0 by 8i, so 0, and as we know sine theta is equal to 0, it implies the general value is equal to theta is equal to 0 degree, but for n pi, theta is equal to sine theta is equal to 0, theta is equal to n pi, where n is integer, where n is 0, plus minus 1, plus minus 2, plus minus 3, and so on. Because if you will take sine pi, then it is 0, plus minus pi, then again it is 0, sine 2 pi, sine plus minus 2 pi, then it is 0. That is why the theta is equal to n pi. For when theta is equal to n pi, the whole the given complex number, this complex number is purely real. So what will be the value of theta? So theta is equal to n pi. When theta is equal to n pi, where n belongs to integer, or n belongs to integer, or n is integer, then it is purely real number. So hope you will understand. Now in the next video we will do the remaining questions of miscellaneous exercise, because the video is becoming very long. So thank you. Please like, share, as well as subscribe my video if you are understanding, and I hope that you will understand very well. And I will make, after completion of the whole ncert, this I will do the complex number questions from other books also, and from IITG mains also. So please, it is my kind request that please subscribe my video, like, share, and subscribe, and please hit the bell icon, so that you will get the notification. Thank you. Bye bye. Namaste. Sat Sri Akal. धन्यवाद.